Hi, my name is James, and this is a Cardano Starter Kit. Today we're going to build upon the work of the last two starter kits to build a transaction that begins to bring us in to the Plutus era, okay? Basically, over the last two starter kits, first I showed you how to build a very basic transaction, just sending some Lovelaces using Cardano CLI. And then in the last starter kit, number 8, we looked at how to mint NFTs by specifically looking at the case of making our own custom unsigs. Today, we're going to tackle IOHK's Lobster challenge. And I said we're going to do it the hard way because we're only going to take a look at the bash scripts that were provided with the original repository. And then we're going to try to build our own transaction by working backwards from what's provided in those scripts. So first, let's take a look. This link is provided in the notes for this starter kit, and you can read about how it works here. There's a whole bunch of files included, including a script that basically does all the work for us. And what we're going to do is we're going to go through here. What you can see is we build a transaction, we sign it, and then we submit it. That's really all we have to do. But in order to get this part right, we got to take a look at what's happening here. Now, if you looked at the last two starter kits, some of this should look familiar. And this is what we're going to cover today. When I look through the original repository, there's instructions, and I really encourage you to read through step by step what you're seeing here. My goal is not to read this document to you today, but to give you a little bit of context so that you're better prepared to understand what's going on here. One thing I want to point out, and that we're going to look at together in just a minute, is that we have a script address that looks similar to just a regular wallet address on the Cardano blockchain. That's pretty interesting, and we're going to get back to that in just a moment. What I'm going to do today, I sort of did number 1 here, but really all I said is that I'm going to let you read that for yourself, but I'll revisit that in just a minute. Then we're going to take a look at the UTxOs at that address that I just highlighted there. Then we're going to look at the shape of the transactions from the last two starter kits. And I want to show you how we're just gradually building complexity from basic transactions to minting transactions, and today to transactions that begin to incorporate some Plutus. We're going to clone the Lobster Challenge repo and see what it provides us. And then we're going to build our own working transaction so we can complete that challenge. I do want to go back and review that repo one more time, because what is laid out for us here is that we can use a bash script, to create, sign, and submit a suitable transaction. I'm not going to use that script. I'm going to show you how to work backwards from what's provided in that script, because basically, and this is something that Roberto showed me months ago when I was trying to learn enough bash to be dangerous, you can really think of a bash script as an outline for how something should work. And I'll show you more about this in a few minutes. But first, let's go to the CLI and take a look at what's here, okay? So a prerequisite to doing what I'm doing here, just like in the last two starter kits, is to have a Cardano node synced up and running, all right? So that's actually, I recognize a big barrier, but if you are able to get this set up, it will unlock a whole array of tools, many of which I'm showing you here in these starter kits. with that running, I can query the tip of the mainnet. I can see that we are in epoch 291, which started on Friday evening, my time. It's the Alonzo era, and you can see my node is synced, okay? Just like before, and I'm actually using the same sender address, all right? This is the address of a wallet that I use to play around on this device, okay? So I can go Cardano CLI, and I can query the UTxOs on mainnet at this address. Cool? And you can see there's a whole mess of stuff here because I've been screwing around with this. There's the leftovers from some of the transactions we built in Starter Kit number 7. There's this UTxO right here, and a couple of other ones that have a whole bunch of CSKU, which is my custom unsigs that I made and created in Starter Kit number 8. But I'm thinking that this UTxO right here should be sufficient for us to use today. So while I'm thinking of it, let's save that as a txin variable, right? So what I'm going to do is copy this transaction hash, open some quotes, put that there with a £, and the index 0. The reason I'm using a 0 is because that's the index I see right here. In some cases, it's not a 0. Okay, so now I've got that saved. So now, just like I saved my wallet address up here as an environment variable called sender, what I'd like to do is make another one called Lobster, quotation marks, put that address there. Okay, and note one thing here. So if I say echo sender and I say echo Lobster, these addresses look similar but not the same. They both start with ADDR1, which is that's kind of like the, what's this? This is like putting an area code on a phone number in the United States. This tells you, okay, this address has to do with Cardano's mainnet. And that prefix is going to be different for any given blockchain, including the Cardano testnet. It has the word test, an underscore and test after it. And if you have an address on Bitcoin, for example, the prefix will be different. But this address is shorter, this script address, because this sender address also has some information about staking on the end of it. Okay, I'm oversimplifying here because this is beyond the scope of this video. But basically, once you register an address as a staking address, it becomes a little bit longer and it has some more information attached to it. The key point for the scope of this starter kit is that we can query script addresses just like we can query wallet addresses. So keep a mental snapshot of this right here. Here's the UTxOs in some wallet that I have, okay? And let me just make some room on the screen here. And then let's say it again. Cardano CLI, we're going to query the UTxOs on mainnet, but this time at the address of Lobster, which doesn't represent a person's wallet. This represents an automated script. The outcome is the same idea, however. There's a whole bunch of UTxOs at this script address. These ones, right? These look familiar. These are kind of just vanilla UTxOs with nothing but Lovelace attached to them. And at the start of the Alonzo era, we started seeing this additional piece attached to every UTxO, right? UTxOs now either have TX out datum hashes attached to them, like the one at the top, and this is where we're going to focus today, or they don't, and they say that. Now, I got to check whether this is right, but I think the reason we're seeing these UTxOs right here is because some folks who tried to complete the Lobster challenge, they might have just sent some funds to this script address, but not included all of the necessary information. And now those funds are at this script address. One of the next things I need to learn about is whether it's possible to unlock these funds or whether they're stuck here. This is something that I just don't know yet, and I got to learn more about how script addresses function. But when we talk about it being a good idea to practice on testnet when you're interacting with contracts and with script addresses, this is why, okay? And when we talk about funds getting locked up, maybe that's what we're seeing here. But I'm not an expert on this yet, and this is one of the next things I need to study. What should be here is this top UTxO. It has a hash, just like every other UTxO. It has an index. It has Lovelaces right here. And then, similar to what we saw in Starter Kit number 8, it's got some various native assets attached to it. It has one Lobster NFT, and you can read about this in the official documentation, okay? I'd like you to go and try to understand what those official notes say after you take a look at this video. Then there's 14,138 Lobster counters. You can read about what those represent in the official repository. And then 337 Lobster votes so far. And basically, this contract is going to run until there are 500 votes here, at which point the Lobster counters will be used to name the red lobster that's been sitting on Charles's microphone. One interesting thing to point out, check out the policy ID for Lobster counter and note that it's the same as the policy ID for Lobster votes. We have two different assets, Lobster counters and Lobster votes, but they're both minted using the same policy. Lobster NFT is not the same. That's a different policy. And this is crucial to running this little challenge because what the Lobster Challenge allows people to do is to mint their own Lobster counters and then send them back to this Lobster address, and to mint their own vote and add that to this UTxO. And I shouldn't say it's not going to be added to the same UTxO. We're basically going to consume this one, add our Lobster counters to it, add our vote to it, and create a new one. So at the end of this video, you'll see that there's actually a new transaction hash. And this is what happens every time somebody votes. But these have to be a different policy because these are open policies. And anybody who tries to interact with this can come along and mint their own vote and mint their own Lobster counters. But they can't access this one, okay, which is a closed policy. Somebody at IOHK, right, has the signing key for this to create the one and only Lobster NFT. All right. So we've got a UTxO. It has native assets. It has a datum hash. And now we're going to play with it. So here in the notes, I just review what I set up to show you that you can save as an environment variable this Lobster address. You can save your own address, and I'm going to need this in a few minutes when I build this transaction, and you can look at the UTxOs for each. Before we move on, I just want to review a little bit about the last two starter kits. You can review these fully on your own. Here's a link to number 7 and a link to number 8. In number 7, we looked at basic transactions, which look like this. All right. You basically, you can take a UTxO as an input, and then you can send some funds to a receiver, send the change back to the person, the owner of the wallet of the original UTxO. You need to set an expiration slot for that transaction. You need to calculate the fee by hand because we're using build raw. And then you sign this result, which creates a signed transaction that can then be submitted. I'm moving quickly through this because you can go back and review number 7 if you want to learn more about building basic transactions on Cardano. Just note that if you do follow along with this now, I made this starter kit right before the Alonzo hard fork. And so the UTxOs in that video won't say plus tx datum hash none, okay? In starter kit number 8, I showed you a bit about minting and using metadata to create NFTs with certain properties attached to them. I didn't cover everything about minting, but the key thing I want you to see here is that the format of how we're building this transaction has a lot in common with how you build a basic transaction. You still have to put a transaction in. You still create an output UTxO, and you specify where to send it and how much change is left. And then this is the syntax for how you attach one or more native assets. Again, go back and review that if you want to take a look. You also need a mint script. And this is the part I didn't focus on too much in that last starter kit. And I'm going to focus on it a little bit right now just to give you that background. This is what it looks like to attach metadata from the command line. And basically, you would have to create the metadata first, draft a transaction, and then calculate the fee, because depending on how big your metadata is, it's going to change the final fee. All right. All that's covered in documentation and in previous starter kits. I just want to review the shape of this transaction here so you can see how much it has in common with a very basic transaction. What I didn't really cover in starter kit number 8, because the docs are really good for this, is how to create your own minting policy. Okay, so just to review, I put a link here. You can read the official documentation. It's really good. You can follow along with that. But basically, if you make a folder and you generate a new set of keys, this is exactly the same function that you would use to create a key pair for your own wallet if you were doing it the hard way. And minting policies need a key pair just like wallets require a key pair. All right. So you would create that pair, a verification key. This is your public key, a signing key. That's your private key. And then you use the public key to generate a key hash. And then you take that hash and you put it in to a minting policy. All right. And this is the minting policy that I ended up using to create those Cardano Starter Kit unsigs last week. So this one, at minimum, you need to specify who needs to sign the minting transaction. And that's basically what this does. This says, okay, take the hash of this policy key. Okay, now with that there, anytime you want to use this minting policy, which we create here after creating a script, anytime you want to use this, you have to make sure that the corresponding signing key is included. Okay. I also included a time-bound parameter here, meaning that, and you can, again, I'm not covering all this, just reviewing. This policy is now locked because this slot has passed on the Cardano mainnet. So actually, this script can't ever be used again because it has this piece right here. All right. But once you create a script, you can then use Cardano CLI transaction policy ID with a reference to this file here. And that will generate the policy ID that we use, for example, somewhere like this, right? This is what I mean by a policy ID, okay? Here or here, right? This is the command that creates that, all right? And then you can use that to create your own native assets. All of this to say that a policy script, right, for minting native assets is just one kind of script. So just like we saw that contract addresses look like wallet addresses, and we can query both of them the same way. General purpose Plutus scripts are going to behave similarly to minting scripts on Cardano. This is a really beautiful point to me, right? We have these similar behaviors of different sorts of addresses and policy hashes, okay? And so when we look at the final transaction we're building today, you should recognize that, yeah, even though now we're using a script that has this .plutus extension on it, it echoes and looks similar to the way we used minting scripts here. This is a really powerful thing to wrap your mind around, right? A lot of these similarities. So again, we're all going to go deeper into this together, but I wanted to expose you to this idea. And if you have a node running, if you have Cardano CLI set up, I recommend you play with this code just as it is right here, right? Try to generate some keys, then create a hash, include it in a policy script, and then you can create that policy ID, all right? All of the documentation you need is on the official docs right here, and hopefully I've showed you enough right here that you can read through and make sense of the official documentation on your own. All right, so now what I've done is I just grabbed the official repository from GitHub, right? Lobster challenge from IOHK. And I cloned it into VS Code just so we can poke around and maybe play with some of this. So this is everything we were just looking at on GitHub. The README file is here with all the instructions. They're much easier to read on that web page. So we'll go back to those if we need to. But I pointed out this is a shell script, a bash script file that is supposed to make it easier for anybody just to go build the necessary transaction to complete the Lobster challenge. Personally, I would rather do this on my own just to really get a feel for this. So what we can do is we can just, you don't have to be perfect at bash scripting to read it and to try to figure out what's going on. Here's what I mean by that. Check it out. A $, as we've covered previously, represents a variable. And if you say $1, usually that's representing the first command line argument. Okay, what's that first argument supposed to be about? Let's see. So I can scroll down here and it tells me, where is that? You can use this bash script to create sign. I covered this earlier in the video, right? You're going to use Cardano CLI. You have to have your node socket set up. I have all that good to go so far. The first command line argument we're going to need is a UTxO with some funds to provide collateral. Okay, cool. That's the txin environment variable that I set earlier in this video. I've got that already. And then the current script UTxO, that's the one I grabbed when I queried the list of UTxOs for the Lobster script address, okay? So when I see, let's see, whoops. When I see those values here, I know that I can change this one to sender and this one to Lobster. And before I submit this, before I build this actual transaction, I'm going to show you that these environment variables are still there, right? But this is all I'm doing. I'm going to go through, I'm going to read each of these variables and try to find what it corresponds to. Okay, so next, so far so good. There's 2 transactions going in. This one is just me supplying the necessary Lovelace to serve as collateral and to pay the fees for this transaction. All right. This one, oh, whoops. I just realized I made a mistake here. this should have been TXIN. This is not the address. Sorry about that, but I'm going to keep rolling just so you can see me fix this. TXIN requires a UTxO. Good. And then I think I called this one TXLob, but I'll check that. And if I didn't, I'll set that environment variable again, right? I shouldn't be using addresses here. I should be using UTxOs. Okay, so inputs. I see some outputs here. So far, so good. But this is new, TXIN script file. This looks similar to the Mint script file, but this is some new functionality. And it takes something that is up higher here called script file. And the script file is supposed to be lobster.plutus. And that script is here, lobster.plutus. Let's take a look at that. Okay, so this is already CBOR encoded. All right, so I can't see where this came from, right? You can write some Plutus, and let me show you this. Here's what it would look like. This is covered in Plutus Pioneers, and we're going to be getting our hands dirty with all of this in the weeks and the months to come. This is the long-term work ahead of us, is to make sure we understand everything that's happening here. But this Plutus code, and it's a HS, it's a Haskell file, compiles to something that looks like this, which can then be included when we build a transaction. All right, so think about this. All the Plutus compiles to something like this, an object like this, which we can then use in transactions. All right, and for me, this is really grounding to see how all of this fits together, right? Now I can see the pathway from writing Plutus code to compiling it to using it to build a transaction. There's more to say about this, and we're going to learn a lot more about the Plutus application backend as it continues to roll out. But for now, that's pretty cool. I could write, and then I can include it in a UTxO, and I can make things happen. And right now, I'm just getting my feet wet by seeing this for the first time with the Lobster Challenge. Okay, so the TXIN script file, why don't I just use that, lobster.plutus right there, okay? Lobster.plutus. And I'll double check that my directories are right when I see what folder I'm in as I'm building this transaction, but that's a good placeholder. TXIN datum value and TXIN redeemer value both are being passed an empty array. That is to say that this is still a relatively simple transaction. Datum and redeemers are both parameters of the validator function in Plutus. There's a lot more to say there. If you want to learn more about it, watch all of the Plutus Pioneers lectures and you'll begin to learn. I'm really excited just to see that these are represented when we build a transaction. And you can rest assured that we're going to be talking a lot more about these in the weeks to come. Cool. TXIN collateral is just referring to number one, the first command line argument, which I already changed to TXIN. So that's just going to reference the same input transaction. Okay. Script address, what's that referring to? Script address is, it looks like it's generated by another script called mainnet script address.sh. Let's go see what that does. Okay, so this just says Cardano CLI address build. Aha, maybe this is where addresses come from. We build an address from a payment script file, and we pass it that mainnet argument just to show that we're using mainnet. Obviously, you could do this on testnet as well. Okay. I want to play with this. So what is this taking? This says the first argument here is the script file. So now I go back here. Script file. Which one? Lobster.plutus. Okay, this makes me want to mess around a little bit. All right, so let's open up our terminal here. And let's make sure, you see, watch this. I'm not going to be able to query mainnet yet because I have to set the Cardano node socket path. So let me just do that. I have a script for this that I'm just going to use very quickly right here. Okay, and this little script helps me set the node, the node socket path. And I also included just querying the tip so I can see that really quickly. Okay, so now if I do this again, yeah, it works. Okay, so now I'm ready to go, and I should be able to run. Oops, now I'm not in the same folder anymore. So now let me switch back to, this was CSKs and Lobster challenge. Okay, and then let's go into the scripts. And so now if I go Cardano CLI address build payment script file is going to be lobster.plutus, and we're on mainnet. What does that give me? That gives me this address. Okay. And sorry about my spacing here. So it's this right here. Does that look familiar? Does that look 1W8433? It ends in JFF. That's this address right here. Okay. So we basically just generated that same address we were querying earlier. Oh, so this is the same as the Lobster address that I saved earlier. Cool. I see where that address is coming from. Okay, let me save that as Lobster while I'm here. Once again, I have to do this again because earlier I was in a different terminal window. And now I'm in the VS Code terminal window. And now I should be able to query the UTxOs on mainnet at that address once again. And I can see precisely what I saw before. Nice. All right. Cool. All right, so going back here, when we reference the address into which we are sending the output of this transaction, it's going to be that Lobster address. Okay, we have to send, what is this? A little more than 2 ADA, a little more than 2 million Lovelace. Let's check this again. That is precisely the amount of Lovelace in the UTxO that we're going to consume when we run this transaction. All right. So that's there. NFT value. What's that? NFT value is 1 Lobster NFT. Well, NFT policy ID comes from here. Now I have a hunch that this is going to be the same policy ID that we see right here for the Lobster NFT, but basically everything is included in this repository to create this policy ID once again. Watch. policyid.sh. Let's see. policyid.sh. Oh, this is precisely what I showed you earlier when we were looking at how to create a minting policy ID. And we can run exactly the same Cardano CLI function to get a policy ID for a script. That's pretty cool. Well, let's see if it matches. We're supposed to use NFT mint policy.plutus, which looks like this. Okay, it's CBOR encoded once again. We can't actually see what's included there. That's good, right? And this is the policy for minting the Lobster NFT. So it's not open, right? But we can still create this minting policy. Let's try it. I hope I'm not losing you here. I'm just kind of walking through the code and doing everything by hand. Let me see. That was policy ID, right? So all I'm going to do is say Cardano CLI transaction policy ID with a script file. Which script file? The NFT mint policy. And that creates this hash right here. CC7, a bunch of 8s. It ends in 419. CC7, a bunch of 8s. 419. Lobster NFT. Cool, that's where it comes from. It's really neat. And so that, which I could copy from here or from here, it's the very same. I'm going to copy that into this transaction down here. You see, this is a helpful script that just does all the work for me. But I want to put this here. Okay, so the NFT value is supposed to be NFT value 1, this ID dot lobster NFT. Okay. So that's what we're going to write here instead. 1, paste, oops, I lost that from the clipboard. Let me go get that again. This, copy this. 1 what? One of these. And this, the capitalization matters, Lobster NFT. And I'll double check all of this. Let me just put on word wrap. So this fits on a line. Okay, so we want one of those, just like is included in the UTxO we're going to consume. We want to send back that one Lobster NFT. So it's the very same one. The L is capitalized and the NFT is capitalized. That looks good. So counter value. Let's see. That comes from here. Counter value. And there's a command line argument. We have to look up what that's supposed to be. The other policy ID. And then dot lobster counter. So we're going to create a certain number of counters. All right. Using this other policy ID. Which policy ID? Well, it's going to be this one right here. And just to show you this, I can once again create this policy ID again by looking at, let's see, where does this come from? Other policy ID. We're still just doing this command, but we're doing it with the other policy file, which is other mint policy.plutus. That too, right? It's encoded, but we can still use it. So let's do it. Should be somewhere up here. Yeah, so instead of NFT mint policy, I want to type other mint policy. Whoops. And I just doubled up. Plutus. There we go. So that FDA 1B6. That's exactly what we see here. And we're going to use this twice. We're going to use other mint policy when we're talking about lobster counter. We're also going to use other mint policy when we're talking about lobster votes. Okay, so I can use that down here. Let's copy that. Counter value. There's going to be some number that I'm going to type in just a few minutes. We'll come back to that after we read the documentation. I'm going to paste FDA16. That looks good. It's the same length as the policy ID for the Lobster, right? Just a good way to check. And this one is called Lobster Counter. And then votes value gets replaced with the similar thing. Same policy ID, but this one, and you could see it down here. This one is, we've got Lobster votes and we've got Lobster counter, right? But same ID for each. Lobster votes. Okay. And we need to figure out these XXs, what numbers to put here, but we're going to come back to that in just a minute. So far, so good. This UTxO datum hash matches precisely what we see here. 45B0 ending in 1C0. And so that has to be included, all right? I don't understand everything about that yet, but it makes sense that we would include that there. That's cool. All right, mint, increase value. Where is that number coming from? Mint, increase value. Okay, this is argument 6, take away argument 5. Other policy. Okay, so basically, let me just grab all of this, copy it, and bring it down here, and then try to understand it. We're going to mint what? We're going to mint some number of Lobster counters. Oh, and I already grabbed that other policy ID here. So let's do that. Let's copy this and paste it over this. And then we're going to mint one Lobster vote, right? Because I'm only voting once, so that makes sense. It's just a question of how many of this other thing. Argument 6, take away argument 5. We'll go back to the docs in a second, but there's another number I'm going to have to fill in. Okay. Mint script file is the other policy file, which we looked at just a few minutes ago. Other policy file is other mint policy.plutus. That makes sense to me as well. So let's just place that here. All right. Mint redeemer value is another empty array. So that looks like something that we're not worrying about yet. And we get to figure this out over the next few weeks, learning how to use this. The change address, that's my address, right? Look, wallet address is the third command line argument. I'll confirm this in just a minute, but when we look at the docs, we should see that the third argument, it's asking for my address to send back to. I'm going to save that as sender here. We will need some protocol parameters. I'm going to download those myself, and we'll make sure that works. And then the out file is going to be called body file. Yeah, I mean, where is that body file? Lobster TX body. I can call this whatever I want, right? Because I'm going to do this myself. This is just the way that this script is set up, but I'm ignoring that. So I'm just going to call this TX draft. Okay, we almost have everything, but we do need some numbers here. So we're going to figure out those numbers. But while I'm here, let's just update this piece too. Okay, so the body file, I just changed that to TX draft, right? It's just the output of what I'm creating when I draft the transaction. This is just bash that's kind of telling me what's going on the command line. I actually don't need this to run Cardano CLI because I'm all set. Signing key file, I'm not going to show you that, but I have an environment variable called sender key. That's the path to my signing key. And this is going to produce an output called TX signed, or I could call it whatever I want. I just have to use the same thing here. This is So tx.signed. All right, cool. So I want to go back to the documentation for a minute and just read what those command line arguments were supposed to be. So the first one, that's the UTxO with some funds. That's my TX in. The second one is that current UTxO. Now this is always changing. And when I started this video, 337 votes had been cast, but maybe somebody else has completed this challenge in the time that I've been making this video. So we'll check on that. We'll make sure we have the right hash for the current Lobster UTxO. File name containing my address. I just want to use a straight up address there. Change address. Yeah, that's fine. It'll just go back to that address because up here, did it grab? Oh, right. So cat just means it's grabbing the information from inside a file. I'm just going straight up. I'm just using that address directly as an environment variable. So I'm good to go there. All right. The fourth parameter, the file name of the, right. Okay. The path to my signing key. I got that set up. All right. Then the last three parameters, the current amount of Lobster counter tokens. That's number 5. The new amount, which I get to choose. I'm going to increment this by a number between 1 and 100, make it that much higher. And so that's why you can see we had 6 take away 5 earlier, which would have created the number of tokens that I'm going to mint. Let's go take care of that right now. All right, so how many do I want to mint? I can mint as many Lobster counters as I want. And again, I hope you read this yourself on GitHub, but basically the idea is everybody can mint a number of Lobster counters between 1 and 100, and those get added to a total, which is at the end, what they'll do is they'll add their secret number to that total, divide by the number of names in the list, and the remainder will provide the index of the name of what the Lobster is going to be, okay? And the whole thing ends when there are 500 votes. So we're going to mint 1 Lobster vote right now, but we're going to mint, but what's today? It's the 20th. Let's do 25, right? On September 25th, the Cardano Summit happens, okay? So let's do 25 more of them. I want to mint 25 Lobster counters and 1 vote, and then that tells us what these numbers need to be right here. The number of votes needs to be 1 more than what it was, and the number of counters needs to be whatever the number was plus 25 more, right? Or whatever I'm minting more. And just like we have to conserve Lovelace perfectly, we're going to have to conserve these native assets as well, right? I got to send back all of them, the ones I minted plus the ones that were there. All right, let's check this out. Let's see if the number of votes has changed. And maybe, oh, it looks like it did, but let me put that higher on the screen so you can see it. Look, since I started this video, there has been another vote. Now there's 338. The counter is at 14,158. Okay, so the number of votes is going to be 339 after I add mine. And the number of counters is going to be 14,158 plus 25 more. What's that? 14,183. And before I submit this, I'm going to check one more time to make sure that that nobody else has voted, because I'm taking my time and kind of talking through this. But we look good here. Let's see. Alonzo Era, mainnet. Put this transaction in, as well as, oh, I'm going to have to update that environment variable. That's fine. Use this script file. Don't worry about datum and redeemers yet. My input serves as collateral. This is going back to the same address. What's going back there? The Lovelace, the NFT, the counters, and the votes. The datum hash stays the same. Here's the minting part. Here's the reference to the minting policy, right? And so in Starter Kit 8 and earlier in this video, this was called policy.script. But as you can see, you can also use a mint script file that's generated by Plutus. The change comes back to me, and yeah, I got to grab those protocol params in just a second. But it looks like as long as I make sure to set these variables, so echo sender, have I done that yet? Okay, I'll be right back. I'm going to make sure to just grab my address and make sure that my sender keys are good to go. Then we'll double check the other environment variables, and then we'll try to submit this transaction. All right, there we go. Yeah, I just went offline for a second while I made sure to get that set up. But if I say echo sender now, once again, there's that address, echo Lobster. Once again, here's a similar but shorter address because contract script addresses are not set up for staking, but this wallet is registered to stake. And then hopefully some of these commands are starting to look really familiar. Let me make sure that I have the right UTxO as a sender, right? And I'm going to call this here. I'm going to copy this address, or not address. This is a UTxO hash. I'm going to copy that and then just show you how I am saving that as txin because that's the variable I'm using. And that was at index 0. So we should be good there. Looks good. And then I want to do the same thing with that Lobster. Has anybody else voted? Nope, we're still at 338. Okay, so the numbers we just figured out should work. Grab this. And I know my camera is overlapping some of this information here, but it's not essential for this piece. So this is going to be, I called this TXLob. You see it up at the top of my screen up here. TXLob is equal to this transaction hash. Okay, and then it's going to be at index 1. Whoops. That's funny. I got it. Copy one more time. Paste index 1. And then just echo that back. All right. Good. So I've got my transactions ready to go. Any variables I haven't covered? I got Lobster set. I got txin and txlob. I have my sender all set. And now I need to grab the protocol parameters. I'm just going to change this file name so I don't have to type all of that. And I'm in the scripts folder right now, which is actually good because the scripts I am referencing in this transaction are also here. Okay, so I'm going to build this transaction and you're actually going to see the draft show up directly in this folder. But let's give this, oh, I need the protocol parameters. Yeah, let me get those. So Cardano CLI query protocol parameters on mainnet with an out file, right? And just to save myself a couple of keystrokes, I changed the name of this out file to protocol.json. And you can see it just showed up over here in the scripts folder where I'm working right now. All right. It looks like everything here should be ready to go. And there's only one way to find out. Let's try it. Now, there's no danger of me running this yet. If there's an error, if I don't get a draft of a transaction here because I made some mistake, I'm going to know about it. So let's just copy all of that. Let's bring it down here. Make room on the screen. Okay. Now, when I press enter, if nothing happens, that's really good. Let's see what happens. Okay. Something happened. Redeemer not redeemed. I wonder, the first thing I want to check here is maybe somebody else just voted. Looks like it. Okay, I just missed my chance. Somebody else just submitted their vote, so this transaction hash is new. It's not the one I have. Let's do it again, and we're going to have to update some numbers. This is awesome. Oh, I'm so glad that happened right now. So the new TX, well, let me show you this. Echo TX lob, it was D5 F5, but it's not anymore. Now it's 3948, right? All right. So let's save that again. Copy. And the new value of TX lob is going to be equal to that new hash with the index. It looks like it's still 1. Okay. And the number of votes went up by 1. So I have to make this 340 instead. And the last person made this number right here increment up to 14,166. So now that's what I want to add 25 to. So what's that going to be? 191. So the last person looks like maybe they added 8 more or something. All right. Let's check again before we run this. No new votes since last time. All right, so I just incremented those numbers. I grabbed a new input, but nothing else is changing. Let's try it again. Copy that. Clear so you can see it. Paste. Whoops. I don't know why that's happening. All right, I'm like clicking and it's automatically copying today. Just playing all the time. I'm used to little bugs here and there. Let's try one more time. Insert that. Let's see. That time it worked because that time I had a valid TX lob, right? A valid hash of an existing transaction. Now let me move fast because I don't want somebody else to beat me to this. Everything else should happen pretty quickly because now that I've drafted that transaction, you could see it over here. Just a big CBOR hash. Hex, excuse me. Okay. Let's sign that file. You should see a TX signed file show up right here, as long as my sender key is correct. There it is. And now I want to submit that file. And if nobody else beat me to it, this is going to work. But if someone else snuck in with that 340th vote, then this is not going to work. And we'll have to go back and do it one more time. But I haven't risked any funds yet because I haven't actually submitted this transaction. All I've done so far is I've built it and signed it. Let's see if it submits. It worked. All right. So what we should now see, I'm going to have to give this a few moments. We can't see it yet because even though my transaction was successfully submitted, it hasn't yet registered because I haven't, there hasn't been a new block yet. So now I'm just waiting in the background for the next block to be created, and that will put once and for all the transaction we just created on the blockchain. Let's see if it's there yet. Nope, still not there. Just waiting. Let's try it again. Aha! Now there are 340 votes. And you see it's exactly what I expected. I just made this transaction right here by interacting with this contract. Man, all right. So there's 160 votes left. We're a little bit more than 2/3 of the way to completing the Lobster Challenge. And I hope that this video has given you some things to chew on. That was really exciting. Contracts and transactions on Cardano the hard way. We're not going to be interacting with Cardano like this forever. I'm showing you this right now just so you can wrap your mind around it and think about what's going on. And as we all get more familiar with all the possibility under the hood, and as we all learn more about what we can do with datum and redeemers, we're going to be making all sorts of interesting functionality come to life. So, here's to the journey. Thanks for hanging out with me today. See you soon.